History is filled with machines that worked and then vanished completely. We are about to explore 20 forgotten technologies that disappeared without a trace, from an ancient computer more complex than anything for 1,000 years to a fire that burned on water. By the end, you will see the past not as a steady climb, but as a story of brilliant flashes that were tragically extinguished. How did a civilization build structures that still stand after 2 millennia, only to lose the recipe? What secret knowledge died with the last person who understood it? The answers reveal a startling truth about the fragility of our own modern world. How secure do you think our current technology really is? That lump of corroded bronze and wood, pulled from the seafloor near Antikythera, was a ghost in the machine of history. For decades after its discovery, it sat in a museum, a puzzling artifact nobody could fully decipher. It was only with the advent of advanced X-ray and imaging technology in the 21st century that its true nature was revealed. Researchers peered inside and saw a universe of precision engineering, a clockwork cosmos built by hand over 2,000 years ago. This was not a simple calendar. It was a portable, hand-cranked simulator of the heavens. By turning a handle, an ancient philosopher could watch pointers move across dials, predicting the exact position of the sun and moon, the phases of the moon, and even the timing of solar and lunar eclipses. It accounted for the subtle wobbles in the moon's orbit, a complexity we now know requires a differential gear, a component so advanced it would not be seen again until the automobile was invented. This device was a tangible expression of Greek astronomical knowledge, a physical model of a universe governed by predictable, mechanical laws. Yet, this spark of technological genius flickered and died. The knowledge required to design and build such an intricate machine, a synthesis of astronomy, mathematics, and metalworking, simply vanished from the historical record. No other device of its kind has ever been found. Its very existence forces us to ask, was this a one-of-a-kind marvel from a single brilliant workshop, or was it a common tool for the learned elite of its time? The Antikythera Mechanism stands as a stark reminder that progress is not a straight line, and that a civilization's most sophisticated creations can be lost to the depths, both of the sea and of time. While the Antikythera Mechanism represented a quiet, celestial intelligence, another ancient secret was pure, unadulterated terror on the high seas. Picture a Byzantine dromon, a sleek warship surrounded by enemy fleets. From its bow, a bronze tube unleashes a roaring stream of liquid flame that dances across the waves, clinging to wooden hulls and sails, creating an inescapable inferno that water only feeds. This was Greek fire, the Byzantine Empire's ultimate naval weapon for over 5 centuries. It was not merely a flammable oil, but a sophisticated chemical weapon that seemed to defy nature itself. Contemporary accounts describe its horrifying effectiveness, a substance that adhered to whatever it touched and roared into an even greater blaze when sailors tried to douse it with water. The secret of its creation was a state secret so closely guarded that it was known only to a select few, perhaps even only to the reigning emperor and a single family of chemists. Its exact formula was a complex concoction, likely a petroleum base mixed with other ingredients like quicklime, naphtha, or saltpeter, creating a mixture that could be pressurized and projected through siphons or thrown in clay pots. This was not a simple tool. It was a complete weapons system requiring specialized equipment and highly trained operators who understood its volatile nature. For centuries, this technological advantage allowed Constantinople to stand unassailable against naval sieges, its walls protected by a curtain of fire on the water. And then it was simply gone. The knowledge did not fade slowly, it was extinguished. With the decline and eventual fall of the Byzantine Empire, the secret died, lost in the chaos of political collapse. Despite centuries of analysis and countless attempts at replication, no modern chemist has ever perfectly recreated its unique, water-igniting properties. So we are left with a haunting question. How could a weapon so powerful, so central to the survival of an empire for hundreds of years, vanish so completely? The story of Greek fire is a stark lesson in the fragility of knowledge itself, proving that even the most formidable technologies can be erased by the passage of time and the fall of a civilization. Yet another pinnacle of craftsmanship was reached not in a workshop of gears and flames, but at the heart of a blacksmith's forge. A Crusader knight would have faced a terrifying sight: a curved blade etched with a flowing, watery pattern, a sword celebrated in legend for its ability to slice through a silk scarf as it fell through the air and shatter an opponent's ordinary broadsword upon impact. This was Damascus steel, a material so far ahead of its time it feels almost mythical. Its creation was an art form spanning centuries, beginning not in Syria but with special ingots of iron known as woot steel, imported from India and Sri Lanka. These raw materials were not pure, they contained secret ingredients within the ore itself, trace amounts of elements like vanadium that would become the soul of the final blade. The master smiths of the era, working without any understanding of modern chemistry, performed a kind of alchemy. Through a painstaking, secretive process of repeated heating, precise hammering, and a carefully controlled slow cooling, they forced the metal to grow internal structures of ultra-hard carbides. This internal architecture is what created the beautiful, wavy surface pattern, a visual map of a blade that was both incredibly hard for holding a sharp edge and remarkably flexible to avoid breaking in combat. It was the perfect balance of properties that modern metallurgy still strives to achieve, and then, by the 18th century, the knowledge to create it was simply gone. The supply of the unique ore from India may have dried up, or more likely, the trade routes that carried it were severed. The guilds of master smiths, who passed their techniques down orally from father to son, may have vanished without a single apprentice learning the final, crucial secrets. The entire science, refined over more than 1,000 years, evaporated. Today, we can analyze the molecular structure of surviving blades. We understand the theory of the carbon nanotubes that form within the steel, yet no one has ever fully replicated the original process. We possess the answers, but we have lost the questions, the intimate, hands-on knowledge of how to make it. How could such a transformative technology, a symbol of power and artistry for an entire era, slip through our collective fingers so completely? The Pantheon's dome still stands, an unsupported span of ancient concrete that has weathered 2,000 years of history. While our own modern structures sometimes crumble after decades, these Roman creations seem to grow stronger with the passing centuries. Their secret was a revolutionary concrete, a material so advanced we are only now beginning to grasp its full genius. Unlike the brittle Portland cement common today, Roman concrete was a living recipe. It mixed lime, volcanic ash known as pozzolana, and even seawater, initiating a chemical reaction that continues to this day. The Roman architect Vitruvius recorded the formula, emphasizing the critical role of specific volcanic materials to achieve a mortar that could set underwater and endure forever. The magic happened deep within the material's structure. Over time, the interaction of seawater with the ash and lime formed rare, plate-like crystals called aluminous tobermorite. These crystals act as a reinforcing skeleton, preventing small cracks from spreading. Even more remarkably, when water seeps into a tiny fissure, it can react with the surrounding material, forming new crystals that effectively heal the wound. This self-repairing ability made it the perfect substance for harbors and aqueducts, structures constantly battered by the elements. Yet, with the gradual collapse of the Roman Empire, the meticulous knowledge of how to mix and place this miraculous material faded. The precise ratios, the selection of the right volcanic ash, the specialized mixing techniques, all of it was lost to the ensuing centuries. Modern scientists, using advanced microscopes, have finally decoded its chemical secrets, but the full practical art remains just out of reach. Why would a civilization allow such a superior, durable, and ultimately more sustainable technology to vanish? Its disappearance forces a humbling question about our own legacy. Are we building a world meant to last for millennia, or one that future generations will need to constantly repair? While Roman concrete reveals a technology we can now almost grasp, another artifact from the past offers no such clarity. A book sits in a vault at Yale University, its pages a gallery of the impossible. Delicate, unknown plants sprout next to celestial charts mapping unfamiliar constellations. Curious fleshy roots dangle from diagrams, and women bathe in interconnected, vibrant green pools, their bodies connected by flowing tubes. This is the Voynich Manuscript, a relic that is not merely old but profoundly alien. Carbon dating places its creation in the early 1500s, yet its contents feel untethered from any known reality. The true mystery, however, lies not in the bizarre imagery, but in the text itself. Approximately 240 pages are filled with a unique, flowing script, an alphabet of characters that has steadfastly refused to yield its meaning for centuries. This is not a case of a forgotten language, but what appears to be a fully developed cryptographic system that has simply vanished. The most brilliant minds in code breaking have laid siege to its pages. William Friedman, the man who helped break Japan's purple cipher during World War II, dedicated a significant part of his life to this single book, and he retired from the challenge utterly defeated. Modern supercomputers have analyzed its patterns, confirming that the text behaves statistically like a real language, with word lengths and character repetitions that follow natural rules. This suggests it is not a random hoax, but a coherent message locked away by a method we cannot perceive. Was it an elaborate cipher for Latin, a constructed language for a secret society, or perhaps a form of steganography where the true message is hidden within the apparent nonsense of the words and pictures? The very system used to create it, the technology of its encryption, is what has disappeared without explanation. This leaves us with a haunting thought. What knowledge was considered so precious or so dangerous that it required a lock for which the key was deliberately thrown away? The Voynich Manuscript is more than a puzzle. It is a silent monument to a form of intellectual security so advanced that even our digital age cannot breach its walls. A magnificent bronze vessel stood in a Chinese court, its surface ringed by 8 dragons, each poised to drop a ball into the mouth of a waiting bronze toad below. This was no ceremonial ornament. It was a machine that could feel the heartbeat of the Earth itself. Invented by the brilliant astronomer Zhang Heng in the year 132, this seismoscope was engineered to detect earthquakes from hundreds of miles away, a feat that seemed like pure magic to those who witnessed it. Historical records recount a day when a dragon suddenly released its bronze ball with a loud clang, signaling an earthquake to the west. Yet in the capital, no one had felt a thing. Days later, a messenger arrived from a distant province confirming a major quake had struck in the exact direction the device had indicated. The court was astounded. How could a machine know the Earth was moving when the people standing right beside it felt nothing? The secret likely lay inside, a hidden mechanism thought to involve a delicately balanced pendulum or a system of weights and levers. When seismic waves traveled from the epicenter, they would trigger this internal system, causing just one dragon to release its ball and point the way. This was not a simple vibration detector. It was a sophisticated instrument of directional analysis, demonstrating an advanced grasp of how energy waves propagate through the ground. It was a technology of insight that would not be seen in the West for over 1,500 years. And then it was gone. No original device survives, and the precise engineering that gave it such sensitivity has been lost to time. Modern attempts to reconstruct it have met with partial success, but the original genius remains just out of reach. This forces a profound question. Why did this groundbreaking invention, a tool that could warn of distant disasters, not spark a continuous tradition of seismic science? Why was it a brilliant, isolated flash that never lit the way for others? The story of Zhang Heng's Seismoscope is a quiet tragedy of innovation, a reminder that a single brilliant idea can emerge and then vanish, leaving no descendants in the pages of history. Buried in the ruins of a Minoan palace lies a small, fired clay disc that challenges our entire understanding of the written word's history. Unearthed on the island of Crete in 1908, the Phaistos Disc is a dense spiral of 45 distinct symbols, from marching men and plumed heads to bees and boats, all stamped with perfect clarity into the clay. This is not handwriting. Each character was pressed into the surface using a pre-formed seal, a unique punch for every sign, making this object the world's earliest known example of movable type printing. It predates Gutenberg's press by more than 3,000 years. The implications are staggering. Someone in the Bronze Age had conceived of a revolutionary idea, the separation of information from the act of writing, using a set of reusable components to replicate a message. The disc's 241 impressions were made in a sequence, spiraling inward from the edge, a deliberate and careful act of composition. Yet this spark of genius appears alone in the darkness. No other object like it has ever been found in Minoan Crete or anywhere else in the ancient world. The punches themselves have vanished, and the script they were created to write remains utterly undeciphered, a locked door with no key. Why would a civilization invent such an efficient method of reproduction and then simply abandon it? Was the disc a royal proclamation, a religious hymn, or a tradesman's inventory list? We may never know its message, but its very existence speaks volumes. It tells us that the path of progress is not a single road, but a landscape of isolated trails, some of which are walked only once and then are reclaimed by the forest. The Phaistos Disc is a fossil of a technological idea that was born, used for a single, mysterious purpose, and then forgotten for millennia, leaving us to wonder what other revolutionary concepts have risen and fallen without leaving a single trace. A small clay jar, no larger than a hand, held a secret that could rewrite our scientific history. Inside, a copper cylinder housed an iron rod, isolated from the metal by an asphalt plug. This unassuming artifact, one of several found near Baghdad, appears to be nothing more than a curious ancient container. Yet, when filled with a common acidic liquid like vinegar or grape juice, this simple assembly becomes something extraordinary, a primitive battery capable of generating a faint electrical current. The discovery, first seriously examined by German archaeologist Wilhelm, suggests the Parthian civilization may have harnessed electrochemistry 2,000 years before it was officially invented. Working replicas have proven the concept, producing just over 1 volt of electricity, a tiny but measurable spark of power from a forgotten age. imagine the possibilities that such a discovery could have unlocked. What use could an ancient artisan have for a steady, low-level electrical charge? The most compelling theory points to electroplating, the process of using electricity to bond a thin layer of precious metal like gold onto a less valuable object such as silver. This would explain the existence of exquisitely gilded ancient artifacts that show no hammer marks, items that have long puzzled archaeologists. A small battery, perhaps connected in a series to increase its power, could have achieved this feat. Other theories suggest a medical or even a mystical purpose, where the subtle tingling sensation from the current was used in ceremonial practices or for therapeutic effect. But here the mystery deepens, for no wires have ever been found. No electroplated objects have been definitively linked to these cells, and no written records explain their purpose. This profound silence is the true puzzle of the Baghdad Battery. If this was indeed a controlled source of electricity, why was it an isolated spark in the darkness? Why did this fundamental discovery not ignite a chain of experimentation that could have led to electric lights or motors in the ancient world? Perhaps the knowledge was held by a small, secretive guild of craftsmen, and their techniques died with them. Maybe the technology was seen as a mere curiosity, a party trick with no perceived practical application on a larger scale. Its existence forces us to confront the very nature of innovation. A discovery, no matter how profound, must fall on fertile cultural ground to take root and grow. The Baghdad Battery stands as a quiet testament to a path not taken, a flicker of potential that glowed for a moment and then vanished without a trace, leaving us to wonder what other foundational truths about our world have been found, forgotten, and are waiting to be discovered all over again. That tiny spark of electricity from a Baghdad jar feels like a whisper from the past, but another artifact offers a different kind of clarity, one carved from pure crystal. The Nimrud Lens is a small, oval piece of rock crystal, ground and polished over 2,700 years ago. Unearthed from the Assyrian city of Nimrud, it feels unnervingly modern in the hand, a convex disc that can focus sunlight into a bright, hot point or magnify small text into legibility. Its discoverer, Sir John Layard, immediately recognized its potential, and modern tests confirm it. This ancient piece of quartz genuinely works as a lens. Its quality is crude, distorting the edges of whatever it magnifies, but its function is undeniable. If this was an intentional tool, it means Assyrian craftsmen were experimenting with the principles of light refraction centuries before such concepts were formally understood. They held in their hands the foundational technology for telescopes, microscopes, and eyeglasses. So why did this path of discovery end so abruptly? Perhaps it was used by a master jeweler to inspect the fine details of a carving, or by a scribe struggling with tiny cuneiform script. It might have been a ceremonial object, a burning glass used to light sacred fires, or even just an ornate piece of decorative inlay that, by pure chance, possessed this remarkable property. The silence of the archaeological record is deafening. No other lenses have been found, no devices that could have housed it, no writings that describe its use. It stands utterly alone. This solitary crystal raises a profound question about the nature of invention. Is it enough for a single individual to discover a revolutionary principle, or does an entire culture need to be ready to receive and build upon that knowledge? The Nimrud Lens is a ghost of a future that never was, a brilliant insight that failed to find its time, leaving us to wonder how many other fundamental truths were discovered, held for a moment, and then let go, vanishing back into the sands. High upon a Peruvian mountain, the stones of Sacsayhuaman fortress do not simply sit together, they embrace. Each massive block, some weighing more than 100 tons, is a unique, irregular polygon, locked to its neighbors in a three-dimensional stone puzzle of breathtaking complexity. The joints are so impossibly tight that for centuries people have said not even a razor blade can slip between them. This is a wall built without mortar, without the wheel, and without iron tools, yet it has shrugged off powerful earthquakes that have leveled modern cities. The method behind this architectural miracle is a secret the Incas took with them. How does a civilization move mountains of stone and shape them with such impossible precision, leaving behind no written blueprints to explain the process? The prevailing theory suggests a feat of almost unimaginable patience. Workers may have used harder stone hammers and bronze chisels to rough out each block's shape. Then the real magic began. They might have repeatedly rubbed one stone against another with an abrasive sand and water slurry, slowly grinding the surfaces until they achieved a perfect mirror image fit. This would have been a monumental task of trial and error, a slow dance of stone on stone until the fit was so seamless it became a single, unified structure. But this explanation, while plausible, cannot fully account for the intricate, interlocking curves and angles seen in the finest walls. This has led to a more speculative, almost alchemical theory. Could the Inca stonemasons have discovered a plant-based chemical compound, a sap or extract that temporarily softened the surface of the granite, allowing them to mold it like clay before it hardened once again into unyielding stone? While no direct evidence confirms this, the idea persists because the alternative, achieving such perfection through pure physical labor, seems almost superhuman. The true genius of the technique, however, lies not just in the fit but in the design. The walls are not vertical, they lean inward, and the blocks are meticulously shaped to distribute weight and energy dynamically. When an earthquake strikes, the entire wall does not shake as a single, brittle unit. Instead, the individual stones, locked in their complex joints, actually dance. They shift and settle, absorbing and dissipating the seismic force, then settle back into place once the tremor has passed. It is a technology of resilience, engineered to move with the earth rather than fight against it. Modern engineers look upon these walls with a sense of awe and humility. We construct with steel and concrete, yet our buildings often fail where these ancient stones have stood for 500 years. The disappearance of this knowledge following the Spanish conquest is one of history's great cultural tragedies. The master builders, their hands-on understanding of geology, physics, and geometry, were lost, leaving behind only their silent, indestructible monuments. What does it say about our own technological age that we can send a rover to Mars, but we still cannot replicate the earthquake-proof walls of a civilization that had no written language? The stones of Sacsayhuaman are a permanent question carved in granite, challenging our assumptions about what true advancement really means. Deep within the crypts of the Hatha temple at Dendera, a stone relief presents a puzzle carved in sunlight and shadow. It shows a large, elongated object like a glass bulb with a serpentine form writhing along its center. This wavy line is held aloft by a supporting pillar, while a cable seems to connect the base to a box gripped by a kneeling figure. To a modern eye, the image is startlingly familiar, a perfect schematic of an electric light bulb. The so-called Dendera Light has become a cornerstone for theories suggesting the ancient Egyptians harnessed electricity. Proponents point to the absence of soot in some deep, enclosed temple chambers, asking how such places could have been illuminated by flickering torches without leaving a single mark. They see the carving not as art but as a technical diagram, yet mainstream Egyptology offers a very different and deeply symbolic interpretation. Scholars like Dr. Wolfgang Waitkus explain that the scene is a rich tapestry of known religious iconography. The bulb is not a bulb at all, but a lotus flower, a potent symbol of creation and rebirth. The snake is the god Harsomptus, depicted in his manifestation as a serpent, emerging from the blossoming lotus to bring life into the world. The supporting pillar is the jed, a symbol of stability, and the cable is a ritual lotus stalk. The entire tableau is a spiritual narrative, not an instruction manual. This clash of interpretations highlights a fundamental challenge in studying the past. How do we distinguish between a literal representation of a lost technology and a profound cultural metaphor that we no longer fully understand? If this was a real device, where is the rest of the evidence? Where are the wires, the batteries, the generators, or even a single written mention of such a world-changing power source? The complete silence of the archaeological record beyond this one carving is perhaps the most powerful argument against the technological theory. Why would a civilization that meticulously recorded its history on every available surface forget to mention its most revolutionary invention? The enigma of the Dendera Light ultimately teaches a lesson about perception. It shows how our own modern world can project familiar shapes onto ancient symbols, causing us to see a light bulb where its creators saw the birth of a god. It is a permanent reminder that the past often speaks in a language of metaphor, and that the most alluring mysteries are sometimes not about what was lost, but about how we choose to see what remains. A 7-meter-tall iron pillar has stood in the open air of Delhi for over 1,600 years, enduring monsoon rains and scorching heat, yet its surface remains smooth and almost entirely free of the rust that devours modern steel in a fraction of the time. The iron pillar of Delhi is not merely old, it is a metallurgical miracle that defies the most basic laws of corrosion. Forged during the reign of the Gupta Empire around the year 400, this colossal monument is composed of 98% pure wrought iron, a material we know today as notoriously vulnerable to the elements. So how has it survived the centuries virtually unscathed? The answer lies in an invisible shield, a thin, protective skin that has guarded the pillar for millennia. Scientific analysis has revealed this layer to be a complex compound called mesowite, a blend of iron, oxygen, and hydrogen that forms a glass-like passive barrier against moisture and oxygen. This protective film did not happen by accident. It is the direct result of a brilliantly unbalanced recipe. The ancient ironsmiths, working without any knowledge of modern chemistry, created an iron alloy with a very high phosphorus content and remarkably low amounts of sulfur and manganese. This specific cocktail of impurities, which would be considered flaws by today's standards, is the very source of its longevity. The high phosphorus likely came from the unique fuel used in their smelting process, perhaps a specific type of charcoal that infused the molten iron with this crucial element. They were not simply making iron, they were crafting a self-protecting material through a process of intuitive alchemy, a technology born from generations of empirical observation and hands-on mastery. This knowledge, however, was not passed down. Later iron structures from the same region rusted away as expected, proving that the secret of the pillar was a fleeting peak of understanding, not a sustained tradition. Modern scientists can analyze the pillar and understand the theory of its protection, but they cannot reproduce the exact, step-by-step art of its creation. The specific ore, the particular furnace conditions, the precise hammering technique, all of these variables have been lost. The pillar stands alone, a solitary giant from a lost school of metallurgy. It forces us to confront a humbling reality. Sometimes the deepest wisdom is not written in books, but is baked into the very materials a culture leaves behind, a silent testament to a mastery we can observe but never quite reclaim. A life-sized human skull carved from a single block of crystal seems to defy the very limits of stone and time. These objects, most famously the Mitchell-Hedges skull, are marvels of lapidary art, their surfaces impossibly smooth and their features rendered with anatomical precision. For decades, they were presented as mystical relics of ancient Mesoamerican cultures, artifacts so perfect they suggested a lost technology for shaping one of nature's hardest substances. Quartz crystal ranks a 7 on the Mohs scale, meaning it is harder than steel and incredibly brittle, prone to fracturing under the stress of traditional carving tools. To create such an object with pre-Columbian tools would have required a method beyond simple hammering and chiseling, perhaps involving specialized abrasives and polishing techniques refined over generations. The legend whispered of a forgotten art, a way to coax form from solid rock using patient, vibrational tools or even sonic resonance. Yet, when these enigmatic objects were placed under the microscope, a different story emerged. Researchers like Margaret Sachs at the British Museum examined the skulls and found telltale marks perfectly consistent with modern, high-speed rotary tools equipped with diamond-tipped bits. These are the signatures of 19th or 20th century workshops, not ancient artisans. The evidence points to a period of fabrication, a time when such curiosities could be made for a lucrative market of collectors fascinated by the occult and the exotic. This revelation transforms the mystery. The question is no longer how an ancient civilization achieved such a feat, but why the allure of a lost technology is so powerfully seductive. Why do we so desperately want these objects to be real, to be proof of a sophistication we cannot explain? The crystal skulls stand as a permanent monument to our own desire for wonder, a cautionary tale that reminds us the most compelling mysteries are not always those we find, but those we are so very eager to create. A city flourished over 4,000 years ago, its streets laid out in a perfect grid, and inside its homes something remarkable was happening. In Mohenjo-Daro, a resident could use a bathroom with a toilet that channeled waste directly into a covered, brick-lined drain built beneath the street. This was not a privilege for the elite. It was a standard feature of urban life, part of a city-wide network of sewage channels that ran for miles, complete with manholes for access and maintenance. The entire city was an engineered landscape, with streets carefully graded to funnel rainwater and waste away from living spaces, and garbage chutes built into the walls of houses for systematic disposal. This was the Indus Valley civilization at its peak, a society that had mastered the art of collective living through hydraulic engineering and municipal planning on a scale that would not be seen again in the region for thousands of years. The uniformity of the baked brickwork, the precision of the sloping drains, all point to a shared, codified knowledge, a common standard for public health that was understood and implemented across the entire metropolis. This was not merely a convenience, it was a profound expression of social organization, a technology of community that required every citizen to participate in its upkeep for the benefit of all. And then this entire system of knowledge vanished. By around 1900 BCE, the civilization that built these marvels entered a period of decline, and their great cities were gradually abandoned. The sophisticated understanding of urban plumbing, the institutional memory for maintaining miles of covered drains, the very concept of city-wide sanitation, all of it was lost. Later cultures in the Indian subcontinent would build great empires and magnificent temples, but they would not rebuild this intricate web of public hygiene for over a millennium. What could cause such a comprehensive forgetting? Was it a slow unraveling of social order, a shifting climate that disrupted the fragile balance of urban life, or perhaps a migration that scattered the specialized engineers and planners who held this knowledge? The silent, empty baths and the clogged drains of Mohenjo-Daro stand as a haunting testament to a simple truth. The highest technologies are not just about bricks and mortar, they are about the shared agreement to maintain them, a collective contract that, when broken, can cause an entire way of life to simply drain away. The harbor of Syracuse faced an impossible fleet. According to legends written centuries later, the genius Archimedes did not just rely on catapults and cranes to defend his city, he turned the sun itself into a weapon. The story describes a terrifying array of polished bronze shields, acting as mirrors, all carefully angled by teams of soldiers to converge a single, searing point of sunlight onto the wooden hulls of the invading Roman ships. At a distance of perhaps a bowshot, this concentrated energy would, in theory, make the timber smoke and then erupt into flames. It was a heat ray born from pure geometry, a defensive system that leveraged a profound understanding of optics against overwhelming force. Modern attempts to validate this legend have yielded fascinating but conflicted results. A team from the Massachusetts Institute of Technology conducted a famous experiment in 2005, using 127 mirrors to focus sunlight onto a stationary, tarred wooden hull. They did succeed in creating a fire, but only under perfect, windless conditions and at a relatively close range. This proves the core physics is sound, yet it leaves the practical challenges of a real battle unanswered. How could the mirrors be aimed and held steady on a moving ship amidst the smoke and chaos of a naval engagement? The complete absence of any mention in contemporary accounts of the siege is perhaps the most compelling argument against its historical use. If such a spectacular weapon had been deployed, wouldn't the Roman historians who documented the siege in detail have recorded the shocking sight of their fleet burning by sunlight? The mystery of the Death Ray is not merely about whether it worked in a controlled test, but why its memory is so persistent if it never existed at all. Perhaps the legend is a metaphor for the sheer brilliance of Archimedes, whose other war machines so astonished the Romans that attributing a solar weapon to him felt like a natural extension of his reputation. The knowledge, if it ever existed, died with him when a Roman soldier struck him down, too engrossed in a geometric diagram to identify himself. This leaves us with a haunting thought about the fragility of a single mind. Could an entire branch of applied science, a technology of focused energy, have been lost in a single moment of violence, its potential snuffed out before it could ever be properly recorded or understood? The story of the Death Ray lies in that shadowy space between fact and folklore, a permanent monument to an idea so powerful we are still trying to prove it was real. A Viking navigator stands on the deck of a longship, the sky a solid sheet of gray, the sea an endless expanse of leaden waves with no shore in sight. Without a visible sun or stars to guide him, his journey across the North Atlantic should be impossible, yet he holds a small, clear crystal up to the sky. This was the Sunstone, a tool of legend mentioned in the old sagas that may have been the key to the Vikings' most daring explorations. It was not a magical stone, but a sophisticated optical device. Crystals like cordierite or Iceland spar possess a unique property. They polarize light, filtering sunlight into distinct patterns that are invisible to the naked eye. By rotating the crystal and looking through it toward the sky, a skilled user could watch for shifts in brightness or color. The point where the light through the crystal appeared most uniform would reveal the hidden position of the sun, even through thick cloud cover or just after sunset. This gave them a fixed reference point, a celestial compass that worked when the sky itself offered no clues. Experimental voyages using replicas have proven the concept works with startling accuracy, allowing navigators to pinpoint the sun's location within a single degree. This technology was not just a clever trick, It was the engine behind the settlement of Iceland and Greenland, and the fleeting Viking presence in North America centuries before Columbus. It was a perfect fusion of keen observation and practical application, born from an intimate understanding of the natural world. Yet, as Viking exploration waned and the magnetic compass arrived in Europe, the sunstone faded from memory. The specific knowledge of which crystal to use and the exact technique for reading the light were never formally written down. They were an oral tradition passed from master to apprentice. When that chain was broken, the skill vanished. How could such a pivotal tool, one that unlocked an entire ocean, simply disappear from the seafaring toolkit of the world? The Viking Sunstone stands as a ghost in the history of navigation, a brilliant method that left behind only whispers in old stories and a profound question. How many other ways of seeing the world have been lost because the people who held the knowledge never wrote it down? A skeletal wooden tower rose from the Long Island landscape, crowned by a massive hemispherical dome. This was Wardenclyffe, Nikola Tesla's grandest and final great project, a monument not just to ambition, but to an idea that threatened to rewrite the rules of civilization itself. Tesla envisioned a world wireless system, a global network that would transmit both information and, more radically, vast amounts of electrical energy directly through the Earth without a single wire. He believed the planet itself was a conductor, and by finding its natural resonant frequency with his giant oscillator, he could send power pulses through the ground and the upper atmosphere, lighting lamps and running factories anywhere on the globe. This was a direct challenge to the wired grids of Thomas Edison and George Westinghouse, a vision of free, ubiquitous energy for all. The tower itself was merely the tip of the spear, a connection point to a hidden energy web enveloping the entire Earth. But the financial backing collapsed, the project was abandoned, and the tower was eventually demolished for scrap. The specific engineering principles behind it, the exact designs for the oscillator, and the method of exciting those Earth resonances were unique to Tesla's genius and died with him. No other engineer took up his precise blueprint. Modern physics allows for short-range wireless energy transfer, like the inductive charging pad for your phone, but the concept of global transmission remains firmly in the realm of unproven theory, viewed with deep skepticism. Was Tesla a century ahead of his time, privy to insights into electromagnetism that we are still struggling to grasp? Or was his grand vision fundamentally flawed? A beautiful miscalculation that could never have worked at the scale he promised. We are left only with the ghost of that tower and a haunting question. What truly failed here, the technology or the society that was unwilling to fund the experiment? Wardenclyffe stands as a permanent symbol of a road not taken, a future of free energy that flickered into existence for a brief moment and then went dark, leaving us to wonder what our world might look like if that single, towering idea had been given power. The soul of a Stradivarius is said to live in its varnish. For centuries, the instruments crafted by Antonio Stradivari in his small Cremona workshop have produced a sound so rich and resonant that it defies imitation, a voice that modern science still cannot fully recreate. While the master's precise woodworking and the unique geometry of his designs are clearly vital, many experts believe the final, magical ingredient was the secret varnish brushed onto the wood. This was not a simple protective coating. Historical analysis suggests it was a complex, multi-layered recipe, a precise alchemy of oils, resins, and possibly even fine mineral powders. The first layer might have been a penetrating sealant to stiffen the wood fibers, tuning the instrument's acoustic response, while the final layers added both a deep, visual glow and a resilient, protective shell. This varnish had to be a perfect compromise, hard enough to protect the delicate spruce and maple from centuries of wear, yet flexible enough to allow the wood to breathe and vibrate with incredible sensitivity. It was a material that fused chemistry with artistry, and its formula was a closely guarded secret of the Cremonese masters, passed down through apprenticeships and within families, never written down for fear of rivals. When that tradition was broken, the knowledge vanished into history. Today, using infrared spectroscopy and other advanced tools, researchers have identified some components like pine resin and the pigment vermilion. Yet knowing the ingredients is not the same as knowing the recipe. The exact preparation of the resins, the specific cooking temperatures, the precise sequence of applying each layer, all of this hands-on wisdom was lost with the last of the great Cremonese luthiers. Countless attempts to reverse engineer the varnish have created beautiful and superb-sounding violins, but none have consistently captured that legendary Stradivarius tone. This leads to a haunting question for musicians and scientists alike. Was the secret truly in the varnish, or did it lie in the natural aging of the wood, a specific density of timber from a little Ice Age forest that can never be replicated? The silent, perfect finish on a Stradivarius is a permanent barrier between our world and a lost peak of artisanal science, a reminder that some forms of genius are not just made, but are also lost with the passing of a single generation. 17th century European explorers arrived at one of the most remote islands on Earth to find a landscape of giants. Scattered across the rolling hills of Rapa Nui stood nearly 900 massive stone statues, the Moai, some as tall as a 5-story building and weighing over 80 tons. Each one had been carved from a single volcanic rock at a central quarry, and then somehow transported kilometers across the island to massive stone platforms along the coast. This was achieved by a society with no wheels, no metal tools, and not a single draft animal to pull the load. The method they used is a technology that has completely vanished. For a long time, the dominant theory was one of ecological collapse, that the islanders cut down all their palm trees to use as log rollers, dragging the statues in a slow, grinding procession that destroyed their environment. But recent experimental archaeology has uncovered a more elegant and far more astonishing possibility. Researchers like Terry Hunt and Carl Lipo tested a method drawn from oral tradition. They attached ropes to the sides of a full-scale replica Moai, and with a coordinated team of just 18 people, found they could rock the colossal figure from side to side, making it appear to walk forward across the landscape. This upright method, with teams pulling in a rhythmic, swaying motion, would have been remarkably efficient, turning a dead weight into a dynamic, moving object. It aligns perfectly with local legends that speak of the statues walking to their altars, powered by mana or spiritual energy. Yet this walking theory is not without its own profound risks. The constant rocking and impact with the ground could easily have fractured the statue's fragile necks or bases, a catastrophic loss for the community that invested immense effort in their creation. And while the experiment proves it was possible, it does not prove it was the primary method used for centuries. The true technique, the complete system of ropes, levers, pathways, and communal coordination, remains a secret the island kept. The eventual deforestation may have played a different role than we first thought. Without the tall, strong palms to make the necessary ropes and leverage devices, the walking of the Moai would have had to stop. The knowledge did not simply fade, it was stranded, a technology that could no longer be practiced in its own homeland. This forces us to see the story not just as an engineering puzzle, but as a cultural one. How does a society forget how to move its own gods? The silent, toppled Moai are not just monuments to a lost engineering method, but to a broken conversation between a people and the very knowledge that defined them. What other forms of movement, what other ways of navigating the world have been lost because the landscape that made them possible was irrevocably changed? Wilhelm Reich's Cloudbuster looked like something salvaged from a forgotten industrial yard. A cluster of long, hollow metal tubes mounted on a movable base, all connected by cables that trailed into a body of water. This stark assembly was not meant for any ordinary purpose. Reich claimed it could literally pull rain from a clear sky or disperse storm clouds, all by manipulating what he termed orgone energy, a universal life force he insisted filled the atmosphere. In the 1950s, this was not merely fringe science, it was a direct challenge to the very foundations of physics. Reich believed that stagnant, negative orgone energy was responsible for everything from emotional blockages in his patients to the formation of deserts and droughts. The Cloudbuster, he argued, acted as a lightning rod for this energy. By pointing the pipes at the sky and grounding them in water, which he considered an orgone absorber, he claimed to create a flow that could break up energetic deadlocks in the atmosphere and restore a healthy balance, bringing rain to parched land. There were anecdotal accounts of success, reports from farmers who swore he ended a drought, or pilots who noted strange, rapid changes in cloud formations near his experiments. Yet these stories were never subjected to controlled, repeatable testing. The entire concept was inextricably woven into Reich's broader, highly unorthodox worldview, a system that blended his background in psychoanalysis with radical biology and meteorology. This fusion made it impossible for the mainstream scientific community to take the hardware seriously, because it came bundled with a theory they had already dismissed as pseudoscience. The end was as dramatic as the claims. Reich's writings were banned and publicly burned by the United States Food and Drug Administration, and he died in prison. With his passing, the detailed, hands-on knowledge of how to build and operate the Cloudbuster, the specific angles, the intuitions about atmospheric conditions, was pushed to the absolute margins of society. So we are left with a haunting question. Could Reich have stumbled upon a genuine, if completely misunderstood, natural phenomenon? Is it possible the Cloudbuster, through some bizarre interplay of metal, water, and static electricity, was affecting localized humidity or ionization in a way that modern meteorology still does not account for? The true mystery of the Cloudbuster is not necessarily whether it worked as Reich believed, but why, after all this time, no one has been able to reliably replicate its alleged effects or definitively explain them away. It stands as a perfect example of how a potential technology can vanish, not because it was proven false, but because the world simply refused to believe it could be true. These patterns of loss weave a common thread through our journey. A technology's survival depends on far more than just a brilliant idea. It relies on a fragile ecosystem of people, resources, and shared purpose. When a master craftsperson takes a secret formula to their final resting place, or when a society fractures and its specialized knowledge scatters to the winds, an entire branch of innovation can be pruned from the tree of progress. The specific volcanic ash for Roman concrete becomes just another pile of dirt without the engineers who understood its properties. The unique ore for a Damascus steel blade is useless without the smiths who knew the rhythm of the hammer and the heat of the forge. These were not just objects, they were conversations between generations, a living knowledge that required a stable culture to continue the dialogue. Even the environment itself can silence this conversation. A single grove of trees felled for rope and rollers can strand an entire civilization's ability to move its sacred monuments, turning a walking technology into a forgotten legend. What becomes clear is that our most advanced creations are not stored in vaults or libraries alone. They are carried in the minds and hands of people and in the health of the world they inhabit. This leads us to a sobering reflection on our own time. Our global digital network feels permanent, a vast, interconnected web of knowledge. But how much of it is truly resilient? If a catastrophic event severed our supply chains or our power grids, how long would it take for the intricate knowledge behind a smartphone or a satellite to become as mysterious as the Antikythera Mechanism? We have centralized our understanding in ways that are incredibly efficient, yet potentially brittle. The stories of these 20 forgotten technologies ask us to look at our own world and wonder, what are we doing to ensure that the brightest sparks of our own era do not flicker and die, leaving behind only silent monuments for future generations to puzzle over?